Hello everybody and welcome back. I finally been able to come back here in the lab after so long time. Apologize for that. But daily business, family and things like that did not allow me to come here. But now I'm here, so we can go ahead with a lot of old projects that still need to be finished, very lot of new projects to be started. So there will be hopefully enough time to go through all of them. Well, I wish to restart the hobby here in the lab with this latest instrument that I have purchased on eBay. It has been a very good deal, and it is something that I always was looking for. This is a 4-output power supply. There are, as you can see, 4 channels, and indeed on this part here where I will zoom in, where you can select what is displayed, we will have channel 2 or channel 4, and over there channel 1 and channel 3. All of them are adjustable but not in the same manner. And let me zoom out. Channel 3 and 4 are just voltage adjustable. Channel 1 and 2 are also current adjustable. So the reason why I wish to have this is for a specific project on a Fluke calibrator, which has all the boards are supplied with 4 different voltages, and more specifically there are dual voltages, plus and minus 5 and plus and minus 12 volts. So this, I believe, should be helpful to test those boards out of the circuit. So, but before anything else, let's go ahead and crack it open and see how it's inside before to go any further. As we can see, it's not in good shape. It's quite dirty. There are some labels, thicker residuals, and over there are some, the paint is a bit scratched, but all in all it's not too bad. And this is the rear, there is the fan, so it should be a bit noisy, hopefully not too much. So let's go ahead and see how this power supply is designed. This is actually my first Tenma equipment in the lab. So let's see how it's inside. The removal of side screws and the top handle should allow me to remove the cover, and indeed it does. Wow, look at that. This is a very good dimension toroidal transformer. By the way, the seller has declared that the unit is not functional. However, in the listing it was showed lighting up, so with the display on, and it just says that can't perform further testing, so perhaps it's also working. It's time to check it. By the way, let's see inside. It's a bit dirty, but all in all, it's not too bad. Probably the light. There are some loose evidence around the capacitors, which I don't like it. Since those when the capacitors are glued like that, most of the time this kind of glue is corrosive and corrode the terminals. So I will check a bit more in depth, but doesn't seem nothing wrong here. So, well, hopefully it will just need a cleaning, and clearly here you can see that is very much yellowed. So perhaps would be nice to make some retrobrighting of the front panel. So let's test the unit. Let's plug it with the power cord and see what it does. The voltage selector is set for 120 volts. So I need to switch to 230, like that. So plugged in, turn it over, and plug it to the variac, power it on. Okay, so let's go ahead and raise up the voltage. We are at 50 volt. Okay, starting to actually do something. Okay, I'm at 150 volt. Let's raise up. Okay. Oh, I see here something that output on. Okay, so it seems that, okay, this is regulating. Channel 4, it's regulating. Channel 2, okay, maybe I have to increase. Okay, is also regulating. And let's see this. And this also is regulating. So it seems that it's working fine. Let's see at full power. Everything looks fine. So let's apply some voltmeter and see the output if match what displayed. Okay, I am on channel 1, and as you can see here, I have regulated to 4.9 volt, and I can't see any output, and yeah, I think there is something wrong. Let's see what it does. Okay. By the way, this should be independent. So, voltage regulation. Yeah, it has some effect, but actually the meter does not read what it should. Let's see channel 2. Channel 2 the same. Let's see channel 4. Let's switch here. We should have 8.6 volt. Well, by the way, here is reading. So it seems that the negative of the channels is not, there is no continuity, perhaps. As you can see, also on channel 3, there is no voltage. Oh, my lead was out. Unbelievable. So let's check it out again. Oh, it's spot on actually. So let's see. 9 volt, which is okay. So let's see channel 4. And channel 4 is also okay. So it's working. Okay, let's try with some load and see what it does. It's not really powerful, however, these two channels are rated at 3 amps. So yeah, let's try to apply some load. Okay, I've regulated the current limit to 3 amps on channel 1, monitoring the output, and applied the electronic load. So I will enable the output, and if we read the 100 scale here, when we reach 3, we are at 3 amps, but it's already tripped. So okay, that will be help in enabling the load. Okay, and as you can see, yeah, it tripped. Okay. By the way, the fan is not working. I don't know if it's something that is regulated by the temperature or should always be on. That would be very, very nice. Well, it seems that the fan is not driving at all. By the way, we are at full power almost, and it's doing fine. 10.78, that's fine. So let's move ahead to channel 2, and okay, channel 2 does not allow me to. Okay, I still need to be more familiarized with this. Okay, let's go, let's say, to 30 volt. Yeah, by the way, I should have tested also the other channel to 30 volts. Yes, let's do it first, that 30 volt maximum. Okay, let's try to the maximum, still on channel 1, and let's increase the current, enabling the output. We have 31 and more volt. Yeah, it's doing fine, at least so far. It's stable, no variation, good regulation. Yeah, it's okay. So let's move to the other channel. This should be moved over there. Whoa. I believe it's charging this circuit on the load. Let's see. Yeah, it's tripped, but it's okay. Okay, it ramp up too quickly. I think it's okay. This power supply is okay. Okay, let's test the fan if there is something wrong. Otherwise, I would say that the power supply just needs cleaning. I left cook the power supply for a while, and the fan started to spin by itself. So I strongly believe that there is a heat sensor, temperature sensor on the heatsink here, and that is really fine since it will be very low noise. Let me try to power it off the load and see if the fan will stop to spin. By the way, it's very silent. Yeah, let's try to see if it will stop. Okay, I've removed the front panel, and this is how the PCBs looks like. They are really well made. There are some strange thing here up on those resistors, which I believe they are limiting resistors and also current sensing. By the way, yeah, the front panel is quite yellowed, as well as the push buttons. By the way, unfortunately, the binding posts, all binding posts actually, are pretty yellowed. And as always, you can't remove the bolt or knob. So I can't make a retrobriting on those binding posts since it will get damaged the metal part. So I had to leave like that. Well, I think I will go ahead and trying some Retrobrite, maybe only on the knob, since also I'm afraid that here also will not be easy. So let's try to do the best. By the way, as you can see, there are a lot of scratches on the display glass here and over the sticker. Okay, let's try to improve a bit the aesthetic of this thing. Okay, this is the final result. I have polished a bit the glass display here. The knobs, well, actually the Retrobrite on the knobs has cured just partially. Only those push buttons has been brought back to gray color. All the others almost remain the same, so it seems that they are not easy to bring back to their original gray. By the way, it's not too bad, and for the lab I believe it's good enough. And I gave also a good cleaning inside here, just with the brush. Well, this power supply is well made. All the connectors are very intuitive. It's not possible to exchange the position one to another one. So I really like this this brand, and this is my very first instrument, if we can call it instrument, in the lab of this brand. This is a USA brand. I actually didn't see where it is manufactured, if it is manufactured in USA or abroad. By the way, the power supply is working fine. I won't just check ripple, so I will get finished the covering and then check also ripples if it stay in the unacceptable, in some acceptable level of ripples. The power supply is finished. Covers are mounted on. I have plugged the probe, and it is by one connected to the oscilloscope. So this noise, it's already in the scope without any power, and if I remove the plug, nothing changed. So let's see if we add some noise while I'm switching on. So 3, 2, 1. Okay. Let me enable the output. Okay, we have seen the charging of the capacitors, but there is no additional ripple here. So it's let's drop down the time scale. Yeah, this looks like let's try to reduce the bandwidth. Yeah, very clean. So this power supply is really nice and very silent. That always in the lab, as this oscilloscope has a fan that get very noisy. This power supply is very silent. I really like it, and it's well manufactured, well done. So I think it's done, and we can add to the lab. So this is the temporary position. I will see later if I will need to move it, but it's well, it's good to have this new piece of equipment in the lab. And I hope you have enjoyed the video, and I'll come back soon. So thank you very much for watching.